The induction motor will look something like this. They turn electrical energy into mechanical energy, which we can use to drive pumps, fans, compressors, gears, pulleys, etc. Almost all the parts are held inside the main housing. At the front, we find the shaft. This is the part that rotates, and we can connect things like pumps, gears, and pulleys to this to do work for us. At the back, we find the fan and a protective cover. The fan is connected to the shaft, and so it rotates and blows ambient air over the casing to help to increase the surface area, and that lets us remove more unwanted heat. The shaft is supported by some bearings, which sit inside the front as well as the rear shields. The bearings help the shaft rotate smoothly and also hold it in position. Inside the housing, we find the stator. The stator is stationary and does not rotate. This consists of a number of copper wires which are wrapped into coils between the slots positioned around the inner. When connected to the electrical supply, the stator generates a rotating electromagnetic field. Connected to the shaft is the rotor. In this case, it's a squirrel cage type rotor. It's called a squirrel cage because it has two end rings which are connected by some bars, and these will all rotate. The squirrel cage is fitted with a number of laminated steel sheets. These sheets will help concentrate the magnetic field into the bars. Sheets are used instead of a solid piece of metal, as this improves the efficiency by reducing the size of the eddy currents in the rotor. When the rotor is placed inside the stator, and the stator is connected to an electrical power supply, the rotor will begin to rotate. So, how does this work? Can connect two coils together and place them opposite each other to create a larger magnetic field. If we place a closed loop of wire inside this large magnetic field, we will induce a current in the loop. As we know, when we pass a current through a wire, it generates a magnetic field. And we also know the magnetic fields will push or pull each other when they interact. So, this loop of wire will also generate a magnetic field, and this will interact with the larger magnetic field. Each side of the coil will experience opposing forces, which causes it to rotate. Inside the induction motor, we have three separated coils which are used to produce a rotational electromagnetic field. When we pass an alternating current through each coil, the coils will produce an electromagnetic field which changes in intensity as well as polarity as the electrons change direction. We need to rotate the coil sets 120 degrees from the previous phase. We then combine these into the stator. The magnetic field varies in strength and polarity between the coils, which combine to produce the effect of a rotating magnetic squirrel cage are shorted at each end, which therefore creates multiple loops or coils. Each bar therefore induces a current and creates a magnetic field. The magnetic field of the rotor bars interacts with the magnetic field of the stator. The rotor bar's magnetic field is attracted to the magnetic field of the stator. As the magnetic field is rotating, the rotor will therefore also rotate in the same direction as the magnetic field to try and align with it.